Hello everyone, I'm Leo. Today I will talk about the strengthening of the Kuroshio currents by intensifying tropical. I will talk about the strengthening of Kuroshio currents by intensifying tropical cyclones. Since the climate warming intensifies and frequency of the strongest cyclones has increased, the experts found that Kuroshio currents transportation has increased too. And then make the prediction that stronger tropical cyclones lead to the strengthening of Kuroshio currents. This picture is the changing rates of AD energy versus distance from TC center. We can see the blue curve is cyclonic eddies, and the orange curve is the anticyclonic eddies. The dot with the circle is the wind speed under than 40 meters per second, and the dot with the square is the wind speed greater than 40 meters per second. And this picture is meant that the cyclonic eddies has more energy than the anticyclonic eddies. Then there is two regions. There's two regions shows the strong seasonal variation of the decade rates of eddies. Both are near the western boundary of the Pacific Ocean. One is located at the eastern of Taiwan, which is in TC active regions, and the other one is located in the Kuroshio extension regions. Then I make tables for to compare these two areas. First is the location, just like the last page I said, and the second one is the AD energy source. In TC active region, the energy is generated from the sharing flows between two other currents. And in Kuroshio intention regions, it has high AD energy from the Kuroshio current itself. And next, in this figure, we can see the blue curve is about the AD energy changing rate, and the orange line is about the stratification, view of stratification. High AD energy changing. There is high AD energy changing in winter and spring, and low in summer and autumn. So it is faced with the seasonal variation of TC's activity. So we can know that maybe TC leads to the AD's field to decay. And here is the Kuroshio in the Kuroshio intention region. It is completely different from the other region area. There is low in winter and spring, and high in summer and autumn, and it is related to stratification. How did the AD affect Kuroshio's current? Before answer this question, I want to introduce the potential vorticity. It is PV. The first point is about the professional definition of the PV. So you can easily just read it. And easily say is it is a concept to predict how the fluid will move and spin, and using fluid dynamic combining about the fluid's density, rotation, and vertical motion. Then it's back to the question: how did the 80s affect Kuroshio currents? Maybe the experts thinks that the eddy flux of PV is the key to answer the question. Here, the region with orange shows the positive PV anomaly. This positive PV anomalies is positive and is negative. The blue one shows negative. The here and here, region here and here shows the negative PV anomaly. And we can consider this is a cyclonic eddy, and this is the anticyclonic eddies. And this indicate here has here positive PV anomaly is stronger than this negative one. So the eddies push the Kuroshio currents toward east, and then the western positive PV flux works to increase the PV of the main components by accelerating the current northward. And this is one of the mechanisms for the acceleration of Kuroshio current in the recent decade. But PV anomaly is not the only reason to affect the Kuroshio current. Here we show another reason is wind stress curl. In picture D and E, we can see that this is a trend of decrease to and compare with B and C. Compare with picture B and C. We also can know that the slope has the significant difference from D and E, just like here and here. So there is still another reason to accelerate Kuroshio currents. Next, we compare the two sections difference. The section 9 and section 3 is from here. Section 9 is here. The blue line here. And the section 3 is the blue line here. Picture A is show the y-axis is about a view that after normalizing. So then A shows that the downstream of the downstream fluid has increased, just like here. And picture B shows that the wind stress curl has decreased. And picture C is AD flux of PV between these two sections, and it is increased, just like picture A. And then we get the picture D shows that the trends of downstream trend of Kuroshio transport is corresponding to the AD flux of PV, and this blue dot is relative about here, the 11 red dot, just like they just turn the view into a figure. Oh, then is talk about the conclusion. The first is the decreasing of the wind stress current affect Kuroshio currents downstream transport. And the second one is the cyclonic eddies strengthen Kuroshio current. Then it is TC's seasonal. This picture is, I want to explain that it is the TC seasonal variation lead to the eddies energy changing. Then it accelerates the Kuroshio current. And it is my presentation. Thank you, everyone.
I'm wondering, how do they calculate the eddy changing rates?
You want to know about how to calculate with the eddy changing rate?
Yeah.
It is, I think, the changing rate is plus all the work to. It is plus all work to all the year. Plus all the works to for one and.
Okay, thank you.
Hello. I was wondering if you know, why is it relevant to study the strengthening of the Kuroshio by the eddies? Is it like for the shipping routes or the impact on the ecosystem, on the meteorology? I don't quite understand why we want to study these eddies and how they strengthen the Kuroshio.
This I don't know how to explain this question. Sorry.
Okay.
I think you mentioned about the Kuroshio's strength, and I was wondering what is the time of making this research, because I'm not sure if the different season may cause the strength of Kuroshio or something.
I don't still know how to explain this.
I want to know what's the unit about the y-axis.
The unit of the y. This is the view after the. It is the view after the. A has installed view, and then it normalize and turn into this dot to here. So it is a normalizing view. It is view after normalizing. So maybe this has not a particular unit.
Well, this is a very difficult paper. So therefore, I think there are several fundamental things that you need to explain. Otherwise, it's really a little bit like a fortune telling. We don't know what all this is about. The first thing is like, go back to your introduction. Okay. In your introduction, it was like motivation, okay? However, I think this kind of motivation is not sufficient. It's not enough. Like, for example, like what Axel said, you need to tell us why should we care about this, okay? If the author, they did not say it, you need to come up with the idea yourself. Why should we care about Kuroshio, okay? And why should we care about how eddy affects it or not? Okay, give us some more background information, the importance of Kuroshio, and then it is a little bit like, you should not expect this to be your purpose statement. Okay, motivation is different from purpose statement. So in my opinion, in this talk, you don't have a purpose statement. So we don't know what you want to achieve with this work. So you need to add a slide saying the purpose statement. Okay, and then And then you can start showing the data. However, you need to consider what is the most essential part, because you need to save some time to explain some basic concepts about about your eddies or about all these things. For example, here you provide an introduction regarding eddy energy. Okay, then I think one of them asks, how do you estimate this? What is the data source? Is it from satellite or is it from research vessel measurements? You should say that, because apparently this is not something that can be measured from a research vessel. So what is the data source? You did not tell us this at all, okay? And I assume that this is, you use this figure to provide a general introduction regarding eddy. This is fine. However, now comes to the, I think this is a little bit not that necessary, okay? I think what is more important is, I think at some point, you start to talk about, this is the key point of your talk. And here, this one, please look for image, okay? Cartoon, image. Use Google image to look for anything that can help you. You shouldn't just throw out this sentence and say, hey, read yourself. This is not acceptable. You should provide image and try to explain what potential vorticity mean. For example, you should always say, if PV is higher, what can we expect? If PV is lower, what can we expect? That's how you explain the difficult term. Okay, now this kind of sentence. You should use a slide to explain this. And then here, you also talk about stress curl. Then you need another slide like this to explain wind stress curl. Okay, because not everyone is physical oceanographer. So you should use image to explain these two basic terms, because these two basic terms, they were mentioned again in your conclusion. So you should all try to make them understand what this basic term means. Then you can go to the data. Okay, you go to the data and then you should, as they said, ask, what are the y-axis? You should say, okay, these are standardized or normalized. So there is no absolute unit. It's a relative measurement, okay? Then you say, okay, this is which section, point that out, and then you should always print keywords on the slide without, you shouldn't just blah, 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 say a lot without printing any keywords. We don't really know where to look at. So this is this one and this one. You should spend more time on this figure, not the first part. Okay, especially this. So here, this is a very straightforward result. Like there's a correlation between eddy PV flux and the Kuroshio transport. So although we don't know how they obtain this value, but this is something that supports your conclusion. So you should say that clearly. Okay, so then based on that, you can reach your conclusion. And then try not to do like a back and forth during your talk. If you need to show where they are again, instead of having this unnecessary header here, you should copy this map and put it here. So you don't need to do this back and forth. Okay, there are more comments I will tell you when I edit the footage. Okay.